talked, we had moved the test date to Tuesday next week, right?
Yes.
Today I want to do a little bit of like integration technique, kind of like supplement. So this isn't attached to a specific section from the textbook. This is just some more integration techniques that I want to cover. We won't do another section of the textbook today. We'll do one on Friday. And then I'll pass out some optimization practice, because we're, during this next test phase, that'll be like the semester one topic that we'll be kind of doing in the background while we're doing the next test topics. And that'll be, we'll do some review questions from you guys, and that'll be for today. Okay?
We're gonna have to work.
What's up?
So are you gonna have time to work then? Like, or not?
It just kind of depends on like what kind of questions you guys have about test stuff, or how much you want that to be an interactive, like whole class thing, or if you'd rather just like, I just want to have some time to review stuff on my own. I mean, that much is up to you. I would say in the 30 to 40 minute range of topic to do, and then after that we'll figure out what we want to do next. Sound good? So this is under like the test 6 topics. These are like, I'm calling this bonus integration techniques. So all these techniques are in place to deal with integrating a rational function. Okay? And now we don't have a technique that'll like is a universal for all rational functions. And even the techniques that I'm going to show you don't cover all rational functions. But they're going to cover a lot more situations than what we were able to handle before, which is basically 1 over x. And this would be stuff that would appear on an AP exam or would appear on test 6. Okay? So I've tried to group these into like 3 categories, because there's going to be 3 techniques that we're going to look at. So the first technique would be used if the degree of the numerator is greater than or equal to 1, and the degree of the denominator is just degree 1. So our example is this function. So the technique that we're going to use here is polynomial division. So you can do long division, or what's easier usually? The synthetic division. Is this piece able to be done using synthetic division? Lucia says yes, that's correct. How do you know, Lucia?
Because you just do like the -4.
So when you look at this piece, this is the piece we have to look at, right?
Yeah.
What do we have to have going on here to be able to do synthetic division?
Just 1x, not squared.
Degree 1, leading coefficient 1. Yes. Does everybody remember that? So we can So we'll set up our synthetic division, right? And what's the first step now that we have it set? Bring the first number down, very good. And then right in the next spot, and then we add down. Everybody kind of remember doing that synthetic division process? Okay, now how do we interpret these numbers at the bottom?
X squared plus 3x minus 15.
Yeah, we want to start at the far right, so that's like our remainder. It's our constant, our x coefficient, and then in this case x squared coefficient. We just kind of keep counting up 1 degree from remainder. So that means that I can rewrite this problem as that, right? Everybody feel good? So my integral of this I can't do the way it's currently written. But if this piece is the same as that piece, that's an integral we can do. So I can go term by term on my integration. The integral of x squared is x cubed over 3, right? The integral of 3x is?
X cubed.
Not x cubed. 3x squared over 2. You see it? We just add 1 to the degree and then divide by the new degree, right?
Oh, okay.
The integral of negative 15 is?
-15x.
Negative 15x. And then to integrate 65 over x plus 4, we need to do a u substitution. What should the u be? X plus 4. Which means that du is going to just equal dx, right? Oops. Everybody's okay?
Mm-hmm.
So I will take the 65 out, and basically we have that. Does everybody see it with the u substitution happening? Hey,
Are we always using u substitution when it's like a multiplication or division or like chain rule?
when you see a composition, almost always it'll be a u substitution. Yes.
Okay.
Yes. And that's a great question, right? As we're getting more comfortable with that process as you guys are reviewing, because that's a test 5 topic coming up. What's the integral of 1 over u? You guys all memorized that. Natural log absolute value u, right? So we have plus 65, natural log absolute value, and then I'll put my value for u back in, plus c. Lucia.
Can you explain how you got the 1 over u du? I get the 65, pulling the 65 out in front.
Mhm.
And
So what I had was I had 65 times 1 over x plus 4 dx. Right, that's the piece I'm integrating.
okay.
So the 65 comes to the front. You said you got that. We said our u is x plus 4. So I replace that. And then when I did the derivative of u with respect to x, du dx is equal to 1.
Okay.
I multiply the dx over, so du is dx.
Okay.
Is that?
Yeah.
So that's one technique, right? When do we use that technique? The degree of the numerator is greater than the degree of the denominator, and the degree of the denominator has to be 1. I should say greater than or equal to. Okay? Does that feel okay? Of the techniques I'm going to show you, this is the easiest. I know. The next one, we would need a degree 0, so a constant, over an even degree trinomial. Now, you can generalize this past this situation, but this is as complicated as I would make it. I don't think I would have like we're gonna have to make a u substitution on this to do it. And to make it more complicated, I would have to add another layer of u substitution to it, which I think is probably overkill.
This is the most that we have to test that substitution.
This level of difficulty that I'm showing you. I mean, you could do it where there's x's in the numerator also, but I would not do that to you. Okay, so here's the trick. The only antiderivative formula we have that involves a rational function other than 1 over x is inverse tangent, right? That's what we're going to try to be making. So the technique here that we're going to be using is completing the square.
Okay.
So in the denominator, I'm just going to be worried about the x squared plus 4x plus 5 piece. Okay? Who remembers the completing the square process from Algebra 2? Did you do this last year in pre-calculus also, completing the square stuff? Probably, but it's a blur. Okay. So to complete the square, first thing we need the leading coefficient equal to 1. We got that. If it's not, you have to do some factoring and just pull a greatest common factor, or pull the factor so that the leading coefficient is 1. Would not be beyond me or the AP to give you one where the leading coefficient was not 1. I know. The next step is we want to add and then subtract right afterwards, b over 2 squared. So that we can do, right? The b value is 4. Does everybody feel okay there? Okay. And the last step would be to regroup and factor the perfect square. So this stuff that I've highlighted in yellow is the piece that's going to make our perfect square. And the perfect square factor is always going to be, the factoring is always going to look like x plus b over 2 quantity squared. I guess it could be minus, depending if it's a subtraction problem. Mark?
Is that?
Yes. And then combining here, 5 plus, or 5 minus 4 is 1. So I have that, right? Okay. So again, as I start, nothing I can do with that. Right? Not the way it's currently written. We'll do the completing the square. I'm going to pull that 7 out front also. Done our completing the square. So this almost looks the same, right? Everybody see that? What am I going to need to do here? I'm going to make a U substitution that'll get it to look exactly like we need. My U is going to be just the x plus 2. Which means that since it's just a linear term, du is just going to be dx. Is everybody okay with the u substitution I made? Now, what is the antiderivative of 1 over u squared plus 1?
Inverse tangent of
Inverse tangent, and then replacing the u with x plus 2. Now, I think that this isn't much more difficult than the division one, but I think students tend to have a hard time seeing when to use this. And like if this number isn't 1 at the end, the algebra you have to kind of walk through to make that work out is kind of a hassle, and we'll see some examples where that happens in the, I give you a little bit of practice for this. Adrian, you have your hand up?
I was just wondering, like, if you can go back to the process.
Yeah.
I get the end part, but how did you get to that, like, 4 over 2 squared minus 4 over 2 squared? Like, I don't understand where that came from.
So I chose to do that. So the second step in the completing the square process is I want to add and then subtract b over 2 squared. So the b here is 4, like the linear term. So I added 4 over 2 squared and then subtracted right after, because that means I'm doing really nothing at all. All I'm doing is finding a new way to write that, because whatever I added, I took away right afterwards, so it's the same as doing nothing. It just makes it look different, which will enable me to factor cleanly.
So then, where does the 2 squared come from?
4 over 2 is 2.
Wouldn't that, but if you're minus, like, subtracting the same thing,
Right, and then,
it'd just be 0.
well, I'm not going to add them back together,
Oh.
right? I want this piece because, this stuff makes a perfect square. That's that stuff there. All the leftovers then, I'm just going to smush together. And that's going to be my leftover stuff. Is that
Yeah, that's better.
okay? Sure.
Does this like work with any type of root? Cube root? Fourth root? Fifth root?
There's no roots. You say root.
Or like any exponent?
Oh, yes. But here's the thing. You would need to pick up. They have to be even, right? You'd have to have like something that's quadratic form, like 6th and then 3rd or whatever, or 4th and 2nd, or 8th and 4th. But if you do that, you're gonna need x's in the numerator for when you do the u substitution, because when you take the derivative of, like x cubed plus 1 or something now is gonna be you'll pick up like a 3x squared, so you'd need like some more x's in the numerator. But yes, it can be done with others, but it has to be like in that quadratic form. Because I don't know how to complete a cube or complete a fourth. Like technically you could probably, like if they gave you just the right setup, you could probably, like do something like that. I would not, no one's gonna expect you to do that by hand. But being able to use tan inverse as like your antiderivative from something like this would be a reasonable expectation. Much more complicated than that, though. It gets like, short of having like some extra coefficients rattling around in there, I don't think anybody's gonna get it much more complicated than this. All right. The last situation is where I have something with degree greater than or equal to 0 over something that's factorable. Okay. And the technique here we're going to use is partial fraction decomposition. PFD, did you guys do this in our pre-calculus? Partial fraction decomposition is what that stands for, PFD. Maybe. Okay, well let's work our way through it on how that's going to work, okay? And again, this partial fraction decomposition process can get really complicated. It would not give you anything that like gets more complicated than kind of the level of example I'm showing you right now. But if like you have repeated terms and stuff, like it can be a lot. If you look at the textbook, they have a section on this and like they go into excruciating detail about all these different situations and how to handle these things. The AP would not give you something that's that over the top. So to do a partial fraction decomposition, we'd start by factoring the denominator. Which should be easy, right? Now, what we want to do is we want to rewrite this as two fractions, right? One of them would be x plus 3 in the denominator, the other would be x plus 2 in the denominator, because when you make a common denominator and add them together, you should get this guy to come back, right? Everybody feel okay? So I'm going to think about this equation. I'm going to solve this equation for a and b. That's my goal now. Once I have that, I'll have a way to rewrite this to where I have just a linear term in the denominator, and I should be able to u sub that out and have something I can integrate. My first step in solving this equation would be to get rid of the fraction. What do I need to multiply both sides of this equation by to get rid of the fractions? X plus 3 times x plus 2. Everybody feel good there? Yes.
How did you get the x plus 3 and the x plus 2 from being multiplied together to being two separate things added together?
That's my goal. That's what I want to do.
Oh.
That's the a and b that I'm having to solve for. I don't know what a and b are, but there had to have been two fractions that I could add together to get that common denominator, right? Everybody feel good with what I got to here? Okay. Now I'm just going to distribute through my a and my b. Everybody feel good there? All right. Now let's think about what we have here. So somehow when I add AX and BX, I have to get just X, right? Everybody agree with that? Because those are all the like terms. So then I can just say that A plus B has to equal the leading coefficient on the X, just a 1. That all feel good? Okay. Similarly then, 2A, 3B, when I add those together, has to give me the constant term, since those things are all constants, right? So I can say that 2A plus 3B is equal to 1. What have I just created? A system of 2 equations, right? I can use this system now to solve for A and B, which will recover for me the 2 fractions that I'd have to add together to get back to the original. Everybody feel good here? What's going to be our preferred method to solve this system?
The top one, A equals 1 minus B is substituted for A at the bottom.
Valid answer. Would not be my choice.
Subtract.
Elimination. Valid answer. Would not be my choice.
Is this something to do with calculus?
With something to do with what?
Calculus?
Not calculus.
Set them equal to each other, since they're both equal 1.
That's still a substitution. That's a good plan, but it doesn't eliminate a variable.
Oh, yeah.
I'm going to use my calculator to solve this by making a matrix and doing RREF on it.
That's easy.
Well, here's why, yes, I think it's easier. Here's why it's easier. The only mistake I can make is inputting things wrong. I can't make an algebra mistake, and the calculator will do it inside of 30 seconds. Where this system, while this is a 2x2, 2 variables, 2 equations, that's not bad. What if, when I factor that thing, I had 3 terms, or 4 terms, or 5 terms, or 10 terms? Now all of a sudden, like, I want no business trying to solve this thing by hand. Give me that calculator and let it do it for me. So here it's like at the breaking point where like, this is not difficult to solve by hand, but you imagine I wouldn't have to do much to make the problem a whole lot more, tedious to do by hand. Would not take a lot. Okay. Oops. This guy, and then give me smaller.
Actually, cool.
Yes, sir.
Why do A and B have to equal 1?
Okay. Because AX plus BX has to equal 1x. Because the x terms have to add together. So the A coefficient plus the B coefficient has to give me the x coefficient.
Okay, thank you.
All right. So to create a matrix in my calculator, if you want to follow along with me, I welcome you to do that. If you have a calculator, you can take it out and do that. If you don't remember how to do this process, it's a good one because, boy, it makes solving a system like trivially quick for us. So the first thing I want to do is before I start any of this, is I have to make sure my system is set up in a way that I can input it into my calculator. So my A's have to line up in a column. My B's have to line up in a column, my equal sign has to line up, and then the constant on the other side has to line up. So all your variables have to line up vertically, the equals line up vertically, and the solution line up vertically. Our system is written that way, because I knew where I was going. To get into the matrix menu, I press second and the matrix button. To enter a data into a matrix, I'm going to go over to the Edit tab. I'm going to select a matrix. I'm going to just select matrix A. The first input asks for the dimension of the matrix. So the first piece is the number of rows. by the number of columns. We have 2 rows, 1 for each equation. And we're going to have 3 columns, 1 for the A, 1 for the B, and 1 for the solution. It'll always be like n by n plus 1. We build one of these things. And I'm just going to type in the coefficients. So coefficient on A is 1. Coefficient on B is 1, equals 1. Coefficient on A is 2. Coefficient on B is 3, equals 1. Everybody okay with how I've inputted it into the matrix? And you imagine this would be quite quick if you're doing this on your own and you know where to go. Now to solve this system with the matrix, I'm going to exit back out to the home screen. And I'm going to go back into the matrix menu. And this time I'm going to go to the Math tab. And the command I'm looking for is called RREF. So I'm going to scroll down till I see that. It's like Command A or something. Oh, B. Oh boy, I pressed the wrong button. I was stopped looking and did something wrong. There we go. Make sure you pick RREF. If you're interested, that stands for row reduced echelon form. Yeah, right? That's some linear algebra stuff. Future engineers, you'll learn all about this. Basically, this is an algorithm programmed into your calculator that's ostensibly the elimination process. Okay? It's doing it with a matrix, so like the operations are a little bit funky, but essentially what it's doing is elimination. And I'm going to do that RREF on matrix A. And it outputs this matrix. This is my answer. The way I read this is each row is an equation. So 1A plus 0B is equal to 2. Or just that A is equal to 2. If I read the second row, that's 0A plus 1B is equal to negative 1. Or just B is equal to negative 1.
How do I change my matrix from like, if mine's a 1 by 1 to like...
You just type the dimension you want over top of it and press enter. So if you want it to be a 2 by 3, you just type a 2 and then enter and a 3 and then enter. And it'll update it automatically for you.
On this tab though?
You have to go into edit.
Okay.
And then in the edit tab, you can change the dimension, you can change the inputs. Is everybody okay with the process here on how I did this on the calculator? Does this ring a bell? Did at some point somebody show you how to do this? Okay. This is a calculus course. I don't need to see you doing algebra. If this comes up on a test situation, you are free to show me this and show me that and give me no work in between as to how you did it. I'll assume you used your calculator to do it, which is fine for me. Everybody okay? Again, in a time test setting, any corners you can cut that saves you, 3 minutes of writing crap down by just using your calculator to skip through those steps is totally doable. All right. So let's back out now. So we wanted the integral of this guy. As it was currently written, no antiderivative formula we have is going to fit that. So we can do our partial fraction decomposition and rewrite this as 2 over x plus 3 plus negative 1 over x plus 2. Everybody okay with what I've done there? The advantage now is that each of those two fractions I can deal with the integral of by just using a separate u substitution for each.
Is it x plus 5 or is that a 3?
That's supposed to be a 3.
Okay.
It's just bad penmanship. So for the first fraction, let's say that my u is going to be x plus 3. That means that du is just going to be dx. In the second fraction, I'll use a letter v this time. That's going to be x plus 2, so dv would just be dx. Everybody feel okay? So up top here, I'd have pull the 2 out, 1 over u du, and then I'll pull the negative 1 out on the other one. I'd have 1 over v dv. So far, so good? So the antiderivative of 1 over u, natural log, absolute value, x plus 3, and then minus 1, say plus negative 1 times natural log, x plus, absolute value x plus 2, plus c. Everybody okay there? Here's the lousy part. If there's a multiple choice question on an AP exam, that's not how they're going to list their answer. What are they going to do? They're going to use their properties of exponent, or properties of logarithms, to combine these into a single logarithm. So the power property allows me to push those coefficients into exponents. Everybody's okay there? And then to negative 1 is the same thing as 1 over, right? And then the addition outside the logarithms allows me to write it as a product inside the logarithm. Dollars to Donut says that's what the multiple choice answer would look like, where we've used our properties of logarithms to combine them together, which is like, ugh, how rude. But this is where the AP likes to test if you're able to simplify to like the simplest answer. This is when they do it, not on the written parts. They don't care there. They check for it on the multiple choice.
I just have a question.
Yes.
Hypothetical.
Go ahead.
So if the equation was the ln of the x plus 3 squared, could it be also minus ln x plus 2 plus c, and you would get the same answer? Because then you would divide it?
Yeah, I chose to, yes.
Okay.
That would be totally fine, yes. Yeah. Yep. So Lucia says, like, could I have thought about this as a subtraction symbol and then use the quotient property instead of the product property? And the answer there is yes, you'll get the same, exact same. Addition of like multiple, or add something times negative 1 times the thing, you add in the negative the same as subtraction.
Even if it's to the negative 1, like in that situation?
What would it make it?
Yeah, because what would happen, Adrian, is it would be that.
No, but I'm saying like, if it was like negative and it was x plus 2 to the minus 1, or would it not be like that?
Well, if it was minus a negative, you just write as plus.
Even the exponent, because the exponent.
So we're talking here at this stage.
Yeah.
If this was minus a negative, we just write it as plus. And I don't do any product property. I would do my simplifying here, where it's easy to do. If you kept it as like negative exponent and then the division, then yeah, like you'll end up with the same thing still, but like the algebra is way messier.
Wouldn't you have to flip it though?
Yeah. That'll end up being the same thing as like just adding without flipping once and then dividing, right? Reciprocal and then divide is the same thing as doing nothing, just multiplying, right? Is that?
Yeah.
Okay. So some good hypotheticals there. Okay. So those are the 3 additional integration techniques I wanted to kind of touch on. Will not be in test 5, because I feel like there's enough in test 5 already. You guys probably agree. So the assignment that I would ask you guys to work on to practice this is just these multiple choice AP questions. I don't know how many I have here. 15 total. Should we do another one of these? Maybe we pick one, you guys can do it, we'll go over it in a minute, and then move on to something else. Sound good to you guys? Let me pick a good one that I think will be a stumper. Look here. I didn't see the one I was looking for. I'm probably in here somewhere. Doesn't really matter. Let's just start with the first one, I guess. So take 5 minutes or so, work on the first one, then we'll go through it together. That ought to do it, right?
That ought to do it.
That ought to do it. Well, you guys are working on that past stuff out. So this is just like a outline of the optimization process. So it's like a list of steps to help when you guys are practicing this additional first semester skill. It's like just a little handout showing you like, what do we need to consider?
Bless you.
Bless you. So again, this is like just a rehash of this. Look at an example here. I might just give you the first sentence. Go with the first sentence. I can make it real easy. This is now I'm passing out the first set of optimization practice. So it should be.
How many total sets are there?
I have this is, I think,
Are we gonna have an optimization test?
we'll do something similar. Yeah, we'll do something similar. We'll have a little 20 or 30 point optimization mini test like we did for the related rates. Your fault. Trouble over power strips.
Is this like what we just did?
This would have been a first semester topic, it's like one of the last things from first semester. But these are classically the two most difficult for students' first semester topics, so I'm gonna try to spend a little bit more, find some extra time to practice these things here in second semester while we're continuing to move ahead.
So like every grade struggles with these topics?
This is traditionally the two most difficult things for students in first semester, are these two things, because they're mostly story problem based, which again, adds like an additional layer of like, now I have to decode
Yeah.
this into what I need it to look like, and then be able to do stuff on it, which is just like, if you have a hard time just doing stuff with it,
Yeah.
the decoding is hard. It adds like an additional problem.
Isn't it 2 minus and I thought you wrote it. This is one. Like you wrote it. As in
Factor the denominator?
Yeah.
Nope, denominator doesn't factor.
minus.
Gotta keep trying, but I won't.
Squared, so plus 1 squared.
There's a tan inverse problem, completing the square problem. Yeah, right? That's the hard part, is recognizing which one to need.
Yeah, that's
I
gonna
just
be the
thought it
hardest
was
part.
like 1 over even
Yeah,
denominator.
yeah, right? So you see that these techniques overlap. The key is that this is not factorable. There aren't two things that multiply to give you 2 and add to give you -2.
Yeah.
So that's your cue that it's gonna be a tan inverse problem.
So.
Ugh, get that.
You right, Patrick?
Now notice, once you're familiar with the 3 options you have, and you recognize which one this is going to be, did you really need to do the problem based on the options that you had here? I would have been able to look at this and go, okay, this is a tan inverse problem. There's only one tan inverse answer. Done, circle, move. Especially in a time test setting, like I'm gonna take some calculated risks where it's just like, I don't need to be sure on this. The time to me is gonna be more valuable if I'm at like 90+%, I know this is the answer, or this has to be the answer. I don't need to be 100% on it. I'm just gonna pick it and go, because the time will be more valuable somewhere else where it's like, okay, I know how to do this, it's just gonna be time consuming for a works.
Where'd the minus 1 plus 2 come from in the beginning?
I completed the square.
That's the negative b.
That's the negative, it's the b over 2 squared and the minus b over 2 squared.
And then you had to add it with both sides, right?
Well, I added and subtracted it. There's not two sides. It's not an equation where something, I'm including complete squares, it's
Solve the
solving.
b over 2.
So then it would basically come out to be like 0, then, right? Because you're,
Right, but you don't, but you don't want to actually combine them together.
okay.
Emma, go ahead.
Can I use a calculator?
Yes.
Is that that's the minus 1 plus 2 is the b over 2, like,
Well, this plus 1 and that minus 1 are the b over 2 squared and the minus b over 2 squared. Right, because this is like minus 2 over 2 squared. And then,
can you like re-highlight which parts are like which parts are square, you know what I mean?
Where did the 2 come from?
the 2's in the original problem. Right?
Oh, you just pulled the 2 out of the place.
I just did I did all the completing the squares kind of in like one shot, aside from the factor it, so you could see at least that much. But that's one I could do in my head. That completing the square, that was an easy one. So I'm going to leave these, let you practice some, take questions next time. I've given you the optimization. I gave you one sheet that, again, just runs through the optimization process, like basically the notes for how to do this type of problem in a one sheet or with no example attached to it. And I gave you 5 practice problems on set 1. These are like the easiest version of optimization problems, mostly just for you to practice the process on something that's like going to be easy to create the equations for, because they're all familiar, like geometric situations, or the situation where I just give you the thing that you need. As we step through, the situations get a little bit more complicated, but I want you to practice on something that'll be, the situation should feel easy on first. We have, what do we have, like 30 minutes or something, 20, 30 minutes left? Do you guys want to do some more test 5 practice stuff with our remaining time? Would you rather do this as a big group, or do you just want to work on it individually and ask about stuff, or?
Will be good.
Okay. You want me to like pick some problems and have you guys try them and then go through them? Get you guys involved? How's that sound? It's kind of like a mix of doing both. Okay. All right, let's see here. Sorry. Of course, go ahead. So just to be clear, this is the kind of problem that would appear on a no calculator portion of the AP exam. Should be a 2-minute or less problem. Just to give you a feel for like how quickly these sorts of things should be done. Who's got the answer? Let's try it. So I would start, I see this, so I want the negative 10 on top. Call that negative x then, that value. So then I can do 5 plus negative x should come out to be negative 3. You guys see it?
Other six, sort of.
There's only one.
That's what I'm hooking together. So I have to flip one of them to hook them together. Since I want to go from 4 to negative 10, it made the most sense to me to flip this one to get the negative 10 up top. But in doing so, I know that makes that value negative. So I just called this thing negative x.
I thought you wanted the bigger value on the top and the smaller value on
Well-
the bottom. That's why we usually flip it.
Yeah, I would typically, but look at the presentation they gave me. They gave me this kooky presentation trying to get me to flip everything and waste my time and get lost in the negatives,
Okay.
right? So like I just said, okay, I'm gonna leave it the way you've given it to me. I'm gonna build this thing out of these parts rather than flipping this thing to put it in the traditional sense. And then I would have to flip this one also, and 2 flips to me feels worse than 1 flip.
So you wanted to get 4 on the same side?
But you could have, I mean, you could have done, Lucia, you could do this, and then you would have to, then the 4 has to be on top here, so we'd have to flip this thing. And then you could hook these together as like, oops, that should be positive 3. I'd have like, so I'd have 3 equals negative 5 plus x. Right? Like you could do it that way too, that's fine.
Yeah.
Doesn't matter,
Okay.
right? Both will come out to the same way. This felt easier to me because I only had to flip one integral bounds, and that made only one negative sign rather than having to do it twice and have double negative chances to screw the sign on the negative or something.
Okay.
But it's fine. You can absolutely do it that way. It's really no longer.
Mhm.
Yeah, Adrian.
Like I get how you did both those, but would it be alright to only flip that like 4 in the minus 10, and that would just make it plus 3? Then couldn't it just be like 3 plus 5 equals x? Is that the right way to think about it?
No, because
Or
this
that
is
not-
going from 4 to 6, and it doesn't go from 6 then to negative 10. Like you have to, like you need the connecting piece.
Yeah, but wouldn't the 4 be that if you flip the first one?
I flip the first one. Yeah, but then this isn't going, then if I do that and I add these together, right, that's going from 4 to 6, and then 6 to negative 10. So I'm going from, oh, this is going from 6 to 4.
Yeah, I'm saying if you were going
What do you-
from negative 10 to 4 and then 4 to 6.
So you only flip the first one, not the other two.
Yeah.
Well, I can't hook those together. Oh,
Like
I'm
from-
saying if you hook the first two together.
From -10 to 4 to 4 to 6.
-10 to,
Can I go to the
and then
bathroom?
4 to 6. Okay. So you want to flip the first one, hook it together to that one. But these are in different spots. If I added these two, that's going to get me 4 to -10. Or I'm sorry, it's going to give me that. Right, you can't hook these two together, Adrian, because it's going from 4 to -10. So you need -10 here to hook to it.
What if you flip, if you flip
But
it?
it, but it doesn't have a -10 there.
No, the
If
other
the
one.
4 is on the top of first.
So you want to take this, so you want this one?
That
Yeah.
one and the second one, yeah.
Okay. You want to do that?
Yeah.
That's fine. Still get you 8.
Yeah.
Okay. Yeah, any of the, like, again, you can hook them together any way that's legal, as long as you're hooking like end of one to start of the other, that's fine. Yes,
Can I go to the bathroom?
yes. Is everybody okay?
Yeah.
Okay, yeah, so lots of ways, right? Lots of ways, that's great. We got it. We're doing good. This looks, yeah, let's do this. That looks hard. I can't, yeah. I guess there's not, you can't really zoom in much more than that because it's so long. Who's got it? This should be a 2-minute problem, remember? Adrian,
Is it E?
I got B.
Same as wrong.
Let's see.
No.
So I know this, right? So this is 9 equals x plus 5. So this guy is 4 then, right? Cool with that? And then this is 7, right? So I'm going to have 1/2 times 4 minus 3 times 7.
I didn't mind.
So the tricky part was getting I think the 0 to 3 of f, squeezing that out of there. But these are classic AP multiple choice style questions where we're hooking stuff together. Let's scroll, find another one.
Concavity.
It's about a bunch of things.
F is less than GC.
Well, this is definitely true, right? That's a property. So for sure, it can only be
Can you explain it?
C or E. I mean, just think about what the picture would look like, right? This is F, and this is G. Is the area under G always going to be bigger than the area under F?
Yeah.
Yeah, right? So that should be, like that piece is obvious. The only question is, are one of these two guaranteed? Because if that's the case, then we can say E, right? Because it's between E and C. Which one's going to be easier to think about?
First derivative.
I would think so too, right? What is the first derivative basically saying? Slope. It's increasing or decreasing this, right? So let's say this is G. That's F. What's the derivative of G? 0, because it's constant, right? Is there any place where the derivative of F is positive?
Yeah.
Yep. So is this guaranteed?
No.
Nope. Okay, then what are we going to say? Only C, right? So I'm just making like a picture to check.
How did you know G was just the non-derivative, which is a straight line?
Well, it just says it's for any continuous G, F and G. I'm going to pick the simplest possible version to analyze. Like, I'm just going to pick an arbitrary G, like G needs to be above F everywhere. I'll just make it a straight horizontal line. F can live below it. That's fine, right?
So you're just like making up.
I'm just trying to find a counterexample, right? I'm trying to think, can I draw an F and G where, like G's always on top, but the slope of F somewhere is bigger than the slope of G. Now, the easiest thing to do is make one of them just a 0, like a straight horizontal line, because the derivatives are easy to see. It's just like, is it increasing or decreasing? Everybody cool? All right. Nice conceptual question there. Let's do 11. I guess I can zoom that in a little bit.
So F is the interval of G.
G is equal to F.
Oh.
Who's got it? Right? So you're just looking for that area. Adrian, what's up?
What is the 1/2?
Area of a triangle. Because that's the, from -1 to 0, it's just a triangle.
Why is it a negative? Why is 1 have negative? Because it's on the.
Because 0 to 1 means we're going that direction. So I flip the bounds. That's where I picked up the negative sign from. So that I'm going like to the right.
How do we know it's asking for the area?
Integral is the area under the curve. Because it was given straight lines, geometry is probably where I need to live at. Hey,
Can you re-explain why it's, you brought up the negative?
so if I'm going from 0 to -1, I'm looking at that direction.
Yeah.
That's not how we're supposed to do it. Area under curve has to go from right to left, if we're calculating it that way. So that's why I flip the bounds and put the small bound on bottom and the big bound on top. When doing so, I pick up a negative sign.
Okay, yeah,
Cool?
yeah, thank you.
Or you can think of just like, if I'm integrating left, everything's negative, integrate right, everything's positive. I don't like to do it that way because, like, what if to the right is below the curve, so I'm like negative, it just gets too many negatives kind of floating around. I'd rather just flip the bounds, write the negative sign, and then do it the way I'm used to doing it. Feels like less flippy floppy in my head to me.
Simple.
Oh, I love this. Piecewise. Oos. What are you going to want first? You could use a graph and do this geometrically. I wouldn't, but you could. No, it's not wrong. It's really not. It's fine. It's no less work. I just wouldn't do it that way. I would do that. Minus 25 minus 9 is 16 over 2. Now, Adrian says draw the graph. You could absolutely do that. It's really no work. It might even be less work if you really think about it. And then if I plug 3 in for this, I have 3, 2. And I plug 5 into that, I have 5, 4. So I'm looking at adding those two areas, right? This is just 2 times 2. What's the area formula for a trapezoid?
1/2 base times height times
1/2 B1 plus B2 times height. The average of the two bases. So these guys are my bases. So 2 plus 4, and my height is 2 there. So that is gonna be 6. Uh-oh, did I get a different value?
Well, I was gonna ask, what are you gonna do with the -3 squared over 2?
I subtracted it, right? 9 minus 25 is 16.
Oh, okay, so you combine them.
Did I goof something up here? Huh, where did I mess up? I don't know, either way of doing it is fine, though. I might have goofed a negative or something here.
The big thing I did say was actually not minus
You're welcome. Have a good day.